In this video, we're going to verify trig identities. We're going to talk also about a couple of approaches and what are some basics that you need in order to get better and faster at doing these. So I like to think of trig identities as a sort of like a puzzle or a game, and that you need to strategize and know what approaches exist to verifying a trig identity, and the basics being how good are you at knowing that cotangent is cosine over sine, tangent is sine over cosine, cosecant is 1 over sine, etc. The faster you know, the faster you get down those basic trig identities, you're going to get better at the Pythagorean trig identities. Plus, you'll get much quicker at the algebra that's involved in being able to verify these. So let's talk about how I tackle these problems. The first thing I do is convert everything to sine and cosine. And then I ask myself, what can I do algebraically, or is there a trig identity that I can change right off the bat, okay, to help me get there? Now, with that being said, I'm always sort of in my peripheral vision keeping what's on the right-hand side, up in front so that I know where I'm going. Now, just to start off, you can always prove that the right-hand side equals the left-hand side, or that the left-hand side equals the right-hand side. So as long as you only show one, right? So I would go only left and then prove at the very end that it equals the right, or the other way around, right? You don't want to go down both of these and start switching both of these. That is not the way this works. I'm pretty sure there's one or two teachers, professors out there that are okay with that, but no, it's usually one side proves that the other side is true. So let's begin. Okay, again, just to get you down to what really is essential here is you need to know your basic trig identities, and you need to recall algebra to some extent, and then you'll get better at the algebra through practice. So whenever you come to a stop, right, you reach an obstacle and you're like, man, I don't know where to go from there. Just go. Eventually, you'll reach a rabbit hole where you're like, you know what, let me erase this and start fresh. But you're learning. Even when you're making a mistake, you're learning. So please don't be intimidated. Just do. So here, step one, I would convert these to, and I'm going to prove that the left is equal to right. That I'm going to have to convert everything to cosine and sine. Here I come to an idea that I might be able to add these, but they don't have common denominators, so please don't. And that's the first roadblock for algebra, right? You have to understand that these cannot be added because these two are different. Okay, as a result, the only thing I got left is just distribute. Now, distributing this might not give me what comes next real quick, right? But just do it. So I'm going to go ahead and multiply the first term with the first, or the cos x with the first term. And that's cos x times cos x. Nothing cancels out with sine x. So I end up with cos squared x over sine x. Okay, move on. The next term here, cos x times, in this case, cos x is in the denominator. So if you are comfortable, you can cross these out or actually show the work that you're multiplying, but try not to get caught up with the baby steps, and then you'll realize that this is just sine x. Now, if you'd like, you can go ahead and always put sine x over 1. In this case, because there was no denominator anymore, you got to remember that cos x was canceled. You come to the realization of saying, well, what's next, right? Algebraically. And so here we have this that we can add, and we again realize that we do not have common denominators. So the only thing left is to sort of visualize that what happens if I were to have sine x here. Oh, I can add them together. So why not do it? So right here, we're actually going to do it. We're actually going to do it in baby steps. So just to refresh your memory with algebra, you multiply the bottom and the top by the same, in this case, trig function. and then you do the math. So I'm going to do the work here diagonally. I didn't do anything to the first term, so I just rewrite it. Now the second term, I did do that modification, so I go ahead and get sine squared x at the top, right? Sine x times sine x. And at the bottom, I just have sine x. Now, the next level you will realize that there's something special about the numerator in that this is a trig identity, okay? And then we'll see what we get with the bottom. Remember, algebra says that the bottom stays the same. So this is going to equal all over sine x. And the top is going to now be able to be added together. And that is cosine x plus sine x squared, right? So cos squared x plus sine squared x is equal to just 1. And this goes back to what I said at the beginning of the video, is that you need to get the basic trig identities down, because the slower you see this, it gives you that space to fill your head in with doubt. So don't get good at being able to get these basic trig identities down. So the result of that is just 1 over sine x, which is cosecant x, and boom, you're done. Leave it alone. The work here is just prove that you're able to do this, and if this was on an exam, you can go back and check your work. But there you go, cosecant x, that proves that my left hand side equals the right, and then you write anything additionally that you have to do in order to prove that it was true. Like some professors say write QED, others say, you know what, this proves that the right hand side is blah 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 blah, right? But for now, for us, just leave it at cosecant x and you'll be okay. Let's move on to number 2. Again, what I really want you to leave this video with is the idea that you can do things algebraically, right? You don't want to memorize these, because you have to remember that when you're sort of given a puzzle, a different puzzle, you might do some things that are similar, but some things that are different. So just sort of build this tool belt of tricks that you could do algebraically to get closer to proving the identity, right? To verifying the identity. So here, let's start off with the basics that we've done before. So why don't we go ahead and just turn everything into sine and cosine. This is 1 over sine x, right? And then minus, this is just sine x, it doesn't change, right? And let's go run with it. Now, at this point, you might be able to see, whoa, there's probably something special going on here. But just finish it, right? So as before, we distribute, we end up with just 1, right? Because sine x times 1 is sine x divided by sine x. That cancels out. And on the right-hand side, sine x times sine x equals sine squared x. Now, if you recall, again, you must be pretty comfortable with the basic trig identities. So like this one, right? This is usually one that appears often. And so if you realize that this is something that we've kind of can derive from this, and if we move the sign over, then we end up with 1 minus sine, oh, I forgot the squared part, sine squared x. And boom, there you are, right? And this, again, is a fundamental trig identity. So you have to get these down. And therefore, we got our answer, sorry. We have cos squared x. So we have that the left-hand side did, in fact, equal the right-hand side. So that's all. There's all there's to it. Now, we're going to go ahead and do the next one. And the third one is going to be a slightly different approach, I think. We'll see. But again, we're going to follow that same process. But this goes to show the following, right? When you see something like this, the strategy to remember, distribute probably. When you see something that is not sine and cosine, the other strategy is convert to sine and cosine. One might happen before the other, but again, now you have two things in your arsenal of tools that you can rely on. So just practice those techniques. And this is what this list of problem is for you to do, is to not focus on does the right hand side equal the left or vice versa, because they do. Your job is to prove using algebra that and a little bit of trig that they are true. So let's go to this third one. Okay. Convert to sine and cosine. So this should be 1 over sine x times 1 plus 1 over sine x. Okay. And then I'm going to prove that this is right. So by the way, if you haven't noticed yet, again, 99% of the time I go from left to right. Very few times that I go from right to left, but it just depends on the problem, right? So here we're going to go ahead and just distribute. Now, the algebra in you might be a little uncomfortable because you normally don't like to distribute with fractions, but hey man, it's time to move up in life and not worry about the little things. So right here, if we distribute to the first term, we have 1 over sine x plus, if we distribute to the second one, just for those of you who might need that baby step, that is just 1 over sine x times 1 over sine x, giving us 1 over sine squared x. Okay? Now again, I'm looking ahead and I'm like, look, based on my algebra experience, whoa. Based on my algebra experience, I know that this is telling me that my denominator better be sine squared x. Now, if you realize what you have here is you have two terms with only one having sine squared x. So why don't we just go ahead and get this to be the same denominator as sine squared so that we can add them together, right? So we've already done this before. So again, please let me do this in a different color. All we're going to do here is multiply the bottom by sine x and the top by sine x. And then we are left with the following here. That's going to give me sine x at the top over sine squared x at the bottom plus 1 over sine squared x. Now we can add, right? So it's sine x plus 1 all over sine squared x. And I'm eager to look at the answer now. And boom, the bottoms match. Do the tops match? Yes, they do. For those of you who are like, well, one's 1 plus and the other one is sine x plus 1. Well, addition is commutative, meaning 1 plus 2 is 2 plus 1 is the same thing, right? So boom, check. We're good here. And we're done. Cool. So what did we learn in this one, right? Well, we keep practicing sine conversion, right? Sine cosine conversion. So if it's cosecant, you do 1 over sine. So we got that down. We got the distribution down. And in this new puzzle, we learn now that, hey, not only do we distribute, but hey, we're building up that denominator up, right? When we see this two terms being added and the sine x and the other one is sine squared x, typically we're going to need to have common denominator to add. There you go. There's your third tool in the arsenal of trying to verify these trig identities. I'm going to do one more, 4, and then I'm not going to do the next two, but number 4 is really going to be almost, well, similar, very similar in answer to that of 5 and 6. So if you do 4, you'll realize the pattern with 5 and 6 and what those answers should look like. Let me tell you what the answer should look like. Let me look, hold on. Keep your seatbelt on. Boom, there's your answer. Boom, there's your answer. That's what you should end up with. So your job is to prove that you can get there confidently, right? And again, the approaches to 5 and 6 is going to be similar to that of 4. So let me just do 4 and then we'll end the video there. In this particular case, I used to say convert to sine and cosine, but in this case, even if it's tangent or cotangent, I would recommend you approach this with the fact that, hey, real quick on the bottom, you can identify that this is a basic fundamental trig identity. So I'm going to go ahead and rewrite that so that I have, let me choose a different color here. I'm going to stick with blue. So I'm going to rewrite everything because my focus is the denominator, okay? Now, some of you might be like, how'd you know to start there? Again, you could start wherever you want, but I saw this trig identity first. So I'm going to go ahead and just knock that out first. If I needed to convert thereafter to sine and cosine, I would. Now, the next thing I do is think about that. Do I need to convert anything to sine and cosine? And I'm like, well, no, it's already sine and cosine. And in this case, I think algebra. Okay, algebraically, can I do something? And again, the way when I originally started doing these trig functions, when I was learning them, I thought cosine squared x as just a. So if cosine x is a, then that's a squared minus a all over a squared. And now this triggers a little bit more of that algebra memory. So then you would be able to factor a out, right? So factor a out, you have a minus 1 all over a squared. And then I could see in my head that I'm going to do some cancellation. So I'm not going to dig more deeper into this. I'm just going to go ahead and, again, build that confidence by doing it with my current function. So then from here, I'm going to factor out the cosine from the top, cosine x. So then cosine x times what gives me my first term, and then cosine x times what gives me my second term. Okay, so cosine times cosine x here, right? That's gonna, if I multiply those, they give me my old first term, then minus 1, and then by doing this, right, this distribution, I should get what I originally had over here. Okay, all that over cos squared x. And then boom, again, algebra sinks in. So then I'm like, okay, I'm gonna use a red pen for this, but algebra kicks in and I'm like, okay, a cancels out with 1a. Right here I have 2, so it cancels out with 1a, and I'm just left with cos x, right? I'm using that algebra mentality, thinking that cos x is just a. And then that equals, right? There's nothing else I could cancel out. That just equals cos x minus 1 all over just 1 cosine x at the bottom. And then I just box it in real quick and double check it. Does this equal the right hand side? And it does. Now, I came up with the last two, so if there's anything wrong, I'll make another video correcting it.